It's on. On. It's on.
I'll check the message.
So, hello my dear, I welcome you all in this session of machine design. So, I also very well wishes to your upcoming GATE examination, that is who are appearing for the GATE 24. Okay, so it's my best of luck to you, and also my dear, whose student who are appearing the GATE 2024. See, at this time the IISc Bangalore questions will set by the IISc Bangalore, but you don't bother about that, कि sir, this time IISc Bangalore question will set, so its question will tough. No, IISc Bangalore never give the toughest question. We'll see some questions related which is according to the IISc Bangalore question in the previous year. But one thing is that the question is very conceptual. That means you must have to study throughout. Okay, so today is the last session of this machine design, and this in which we have to I include this in this challenging question some very good questions, so that you are very comfortable with that your level, to check your level, okay, according to this question. That is the main motive. So we are not wasting much more time, and I will start the today's first question. Let's see the today's first question. Yes, read this question carefully. Read this question carefully, beta. So the first question is related to the gear. Okay, so in the machine design, the only we have to design the spur gear. Okay, don't bother about the other type of gear. Okay, during the design of machine element. Okay, so what is that? A 20-degree full depth involute spur pinion of 4 mm module and 21 teeth is to transmit 15 kilowatt at 960 rpm. Its face width is 25 mm. Given that the tooth geometry factor is 0.32 and the combined effect of dynamic load and a allied factor intensifying the stress is 1.5. So it is nothing, it is a dynamic factor. Okay, the minimum allowable stress in megapascal of the gear material is. So we have to find the allowable stress. We have to find the allowable stress. Okay, my dear. So let's start this one. Okay. Now, what is that? A 20-degree full depth. So that there is a gear, and we have to design the gear. That means we know that if you find the strength of the material, see, this is the stress, allowable stress. That means the stress we have to find. So how to design the strength of the gear? We have to design the strength of the gear according to that beam strength. What is the beam strength, beta? Beam strength. What is the beam strength? Beam strength. It's beam strength. That means we have to, this is tangential force. The force which is tangent to the tooth. That means this is tangential force, which tangent to the pitch circle. This the force, it is the tangent to the pitch circle, and it is act perpendicular to the tooth, perpendicular to the tip of the tooth. Okay, so this is equal to, so tooth act as a cantilever beam, so it will be a bending stress sigma b into width of the tooth b module and Lewis factor. This is your formula which is used in this one. Okay. Now, so in this one, this is your working stress. this is your working stress. This is your working stress. Working stress. Clear? This is your working stress. This is your working stress. Okay, and this is your width of the tooth. Width of tooth. This is your width of the tooth. This M, what is M? Module. This is your module, and this Y, it is your Lewis form factor. Form factor. It is given in the question. Okay, now start. What is given here? Module, it is given full depth 5 mm module. So module it is given. Number of teeth, T it is given. Yeah, you can say that Z, no problem. Number of teeth, Z it is given. Power transmission it is given, P. N it is given, RPM. Face width, B it is given. Given the tooth geometry factor, this is geometry factor, that means Lewis form factor, Y it is given. Combined effect, and also you have to take consideration of the dynamic effect. So this the value which is considered according to dynamic effect, that is your 1.5, and this is denoted by CV. Okay, minimum allowable stress, that means you have to find this value, sigma B. Okay, that is the main thing. Clear? So let's start this question. All the data it is given. So start this one. Okay, take, no problem. So we know that Ft, tangential force, sigma B M, yeah, sigma B into B M Y. Okay, this you know. Now, so my dear, here we don't have any, and power transmission it is given. What is given here? Given module 4 mm. Okay, teeth of the pinion 21, power transmission 15 kilowatt, that means 15 cross 10 to the power 3 watt. Yes or not? Thank you, Ishita. Thank you. Okay, in RPM it is given. How are you? 960 RPM. How are you, Ishita? Okay. Face width it is given 25 mm. These all values are given. Lewis factor it is given 0.32, and coefficient of velocity 1.5. You have to find beam strength. Beam strength. Thank you, Sandeep. Okay, beam strength we have to find. So first, if you find the beam strength and the power transmission data it is given. So from the power transmission, you can easily find what is the torque transmitted. Okay, so power transmission, power transmitted, power transmitted, that means P. And what is the power transmission? Torque into harmony, torque into what is the power? Torque into angular velocity omega. We know that. What is the torque and what is the angular velocity? Okay. What is the angular velocity? What is the angular velocity? 2 pi n upon 60. Why 60? Why? Because n it is in RPM. Clear? Thank you. Okay. Now the power transmission, the transmission by the pinion, what is the power transmission? It is given. How much? 15 cross 10 to the power 3. From you all sides. From you only, beta. From you all of you with me, that gives the more and more power. Your presence and your reply gives more power and automatically I will boost. Okay, and that shows, okay, what is 2 pi n? Yes, 2 pi n opportunity. So this is okay. Now, so and the power transmission, so you have T into 2 pi n. 2 pi you have, n value you have, n value you have 60, multiply and find the torque transmitted. Now, once you have to find the torque transmitted, so due to this torque transmitted, so what is the torque? Force into perpendicular distance. What is the torque? Force into perpendicular distance. If there is a teeth is there and the force, we have to provide the force, tangential force, this force Ft. That tangential force into this length gives the lever arm effect. That means it will try to rotate it. So Ft into this length will gives the torque. So indirectly from here you have to find easily what is the tangential force that are applied on the tooth. And that tangential force is responsible to rotate the gear. Okay. So tangential force due to this torque, due to this torque T, that means you have this torque T. So what is the tangential force? You can easily find. What is that? Ft, tangential force, torque by R. R is the radius. R is the radius. And what is the radius? This radius is what? Radius of what? Pitch circle. Radius of pitch circle. Radius of pitch circle. Okay. So from here you can easily put, so R. Now my dear, you can here you have, now what is R here? How to find radius of the pitch circle? How to find? Please tell me. How to find the radius of pitch circle? You have to find the radius of pitch circle with the help of module and the number of teeth. What is the relation between module and number of teeth? We know that diameter of the wheel, that means diameter, pitch diameter, D is equal to module into number of teeth. This is, if you don't know this formula according to the theory of machine, so you cannot able to solve. So what is the module here? Module here is 4. What is the teeth value? 21. How much it is, beta? Please tell me. 84 mm. So what is the radius? R. 42 mm. So 42 mm is the radius of the pitch circle. Now, so you have this value. What is the torque here? If you rearrange this, 15 cross 10 to the power 3 into, it is your 60 above, then divided by 2 pi n. N is how much? 960. Okay. Now, so this is your torque. This is torque. But this torque is a Newton meter. This torque, it is your Newton meter. But here R value is your mm. So just you have to multiply with 10 to the power 3. So this is your Newton mm. What is the torque unit? Newton mm. So This is your Newton meter. If you not multiply 10 to the power 3 and put 42 mm, it's have a chance to mistake. So this is your Newton meter multiplied with 10 to the power 3, that is your Newton mm into divided by 1 by this 42. Up to that there is any problem, please tell me. Up to this there is any problem, please tell me. So if you rearrange this, if you calculate this value, the tangential force which is transmitted, it is your 3552.26 Newton. So that much amount of the force is required to rotate this gear or a pinion. Now you have Ft. Now my dear, if you put directly Ft here and all the value, you have a mistake. Why? Because here the dynamic effect it is given. This is very important, I am telling you. This dynamic effect it is given. Yes, if it is not given, you can directly put this value here and find it. But here dynamic effect it is given. So we have to consider the dynamic effect. So how to consider the dynamic effect? You can find the effective tangential force. How to find the effective tangential force? If you find the effective tangential force, that is your Ft into Cv. If Cv it is not given, then you have to directly put this Ft into this equation. But here the dynamic effect you have to consider in the question. In the question itself say that. In the question is and the combined effect of dynamic load and allied intensified factor it is given. So you have to calculate. So how to adjust this one? How to adjust this one? So since, very important, note, since we will consider the dynamic effect so dynamic effect, that means Cv. So F T effective is how much? Cv into Ft. Okay, put this value here. So put this value. What is Cv? 1.5. What is Ft? 3552.26. So it is your 5328.85 Newton. So this is your Ft effective. Now once you have Ft effective, then this value will have to put into the Lewis beam strength, So what is that? Ft effective is equal to sigma b into b module Lewis factor. Okay. So what is the F effective? 5328.85. 5328.85. We have to find sigma b into, what is b value? Face width. It is given b 25 mm. Put all value in mm. What is module? 4 mm. Lewis factor. How much the Lewis factor? 0.32. 0.32. So here the sigma b, it is in megapascal. 166.52. Simple. Very simple. That's it. Clear? Clear, beta? Everyone, please tell me. This is clear or not? Please tell me, beta. This is clear or not? This is clear or not? Please tell me, everyone. This is clear or not? Please tell me, everyone. Now, So we have to go to the next problem. See, this is your next problem. Really, this is very good problem. See this one. What is that? See this question. This question is very good question. Yes, nice question. Clear. Thank you. Now read this question. Read this question. One tooth of the gear having four module and 32 teeth is shown in figure. Assume that the gear tooth and the corresponding tooth space make equal intercept on the pitch circumference. The dimension A and B respectively are closest to. What is the value of this A and what is the value of this B? Okay, this is your pitch circle. This is very good question. Now we have to start, but one thing is here, in the question it is given, you must have to consider this one. What is the given it beta? Assume that the gear tooth, what is the tooth of the gear, is equal to the corresponding tooth space. That means what is the tooth is there, same is equal to corresponding to tooth gap. That means how to say, what is this, what they are saying that, this says that, let's suppose my dear, let's suppose one second beta. Okay, so this is your tooth of the gear. Now, this is your pitch circle. This is your pitch circle. We have to measure all the dimension from the pitch circle. This is your pitch circle. This is your center. So this is your pitch radius R. No problem at all. Now this says that you have to measure, this is a circle, so you have to measure all the dimension from the circumference of this circle. So this is tooth space, tooth thickness, and this corresponding to tooth space, that means A, B and C if you take. So this is your pitch circle, pitch circle. So this AB, in this question this says that AB is equal to BC. Clear na? AB is equal to BC. That means what this says that gear tooth, assume that the gear tooth thickness and corresponding to the tooth space is equal. That means this AB is equal to BC. This is given. Now, now my dear, one thing is that this, if you draw the circle from above this one, so this is your addendum circle. What is that? Addendum circle. And this pitch circle to this addendum circle is known as addendum. So this is your addendum. This is your addendum. That means from the addendum circle, that means radial distance from the pitch circle to the addendum circle is known as addendum. Clear? Now, what is the circular pitch here? What is the circular pitch? circular pitch. So from here you can easily find circular pitch. So let's take some look for this one. Why? Because there must be some information you have noted here, so that you are not get more you are not confused. So circular pitch, you know that circular pitch is your PC, and this is your pi d upon number of teeth, pi d upon teeth, number of teeth. What is the circular pitch, beta? How to measure the circular pitch? This is your distance between AD, that means this one. AC, distance between AC. This distance between AC is your circular pitch. A and C. So that means, see, so this is your this. That means this distance. If you measure this distance, this one, this is your circular pitch, PC, circular pitch. That means circular pitch is equal to tooth thickness T, let's suppose tooth thickness T and tooth space S. This is your circular pitch. Tooth space S and tooth thickness. This is your tooth thickness T and this is your tooth space S and this is circular pitch PC. Clear? So this is your distance between this A and B, and this is distance between A and C. A and C. This is your circular pitch. Okay. So from figure, circular pitch is equal to tooth thickness plus space. Okay. And these two are same. It is given in the question, tooth thickness is equal to tooth space. It is given. If there is no any, this is your standard assumptions. If it is not given, you can assume like that. Tooth thickness is equal to tooth space. This is your standard assumption. And it is also in given. When this assumption is valid, when there is no any backlash, if there is no backlash, there is no backlash. This is not. Backlash, okay. That means from this one, circular pitch is equal to 2 into T. 2 into T. Clear? 2 into T. Now, see my dear, this is the first assumptions you have to assume while designing. The second one assumption is equal to beta, there is no any addendum value it is given. See, if there is no any addendum, that means, see my dear, this is your tooth. What is given here? See this one first. Okay, we have to draw the tooth. Okay. Done. This is your tooth. Okay. And this is your pitch circle. See, this is your pitch circle. To draw the pitch circle from here, let's suppose this is your pitch circle. Okay. This is your pitch circle. Clear? That means this point from here to here. This is your pitch circle. Okay? This is your pitch circle. And this pitch circle, we have to measure all the dimension from this pitch circle. Clear? So, this is our, the given value it is given in the question, it is like, look like that. Okay. Okay, one second. Okay, from here, the dimension it is given. This is given. Yes or not? This dimension it is indicated. What this dimension it is given? It is given B. Yeah, A. What is given, what I say here? This is your A. Dimension A. So, this is your A dimension it is given. Clear? This is your A. Now, from here, it is also given this B. This dimension is given B. This dimension it is given B. This dimension it is given B. Yes or not? Please check it. Please check it. Please check it, my dear. This is your A and this is your B. And see, this is your B, this is your A, and this is your pitch circle. And this is your pitch circle. Clear? This is your pitch circle. Now, my dear, from this pitch circle, if you draw the line here, from here to here, okay, good. Now, see, my dear, from this line, this point, you know this thing, from pitch circle to the top of the teeth, what is the distance? From pitch circle to the top of the teeth, what is this value? It is your addendum. This value, it is your addendum. This is your addendum. Okay, nothing it is given, this distance, nothing it is given addendum information, you can assume one module. My dear, one module. My dear, this is very important assumption you according to design data book. This is your standard assumptions. If you don't know, you cannot solve this problem. Not solve. So addendum is equal to one module. Okay. Now, so my dear, if you find the B distance, module it is given. Let's suppose this distance is your y. No problem. Let's suppose this distance is little bit y, x. Okay, this is your x, and from here to this center, let's suppose this is y. Clear? And this is our radius, yes or not? This is our radius from here. This is our radius, yes or not? This is the radius of the circle. Yes or not? This is our radius, r. Okay. And what is the value of r? Please tell me. What is the value of r? It is given or not? Yes, module and teeth it is given. So we have find, that means, what is that? Module it is equal to 4 mm, it is given. Teeth is equal to 32. So what is diameter? T into m, that is 128 mm. So what is the radius? 64 mm. Yes or not? The radius of this circle is 64 mm. So this is your 64 mm. Clear? Now my dear, finish, now finish. What is the pitch circle here? Pi d upon z. This is your pitch circle, and we have pi, what is d? 128, and z is 32, I think, yes. So what is the pitch circle? This is your 12.566 mm. Now we already know that this pitch circle is equal to 2 into t. 2 into t, and t is what, beta? T is what? Tooth thickness, and here the tooth thickness it is given. What is the tooth thickness? A. Tooth thickness here, tooth thickness is A, it is given. So tooth thickness, this is your tooth thickness. Tooth thickness. Tooth thickness is given, and given condition is that pitch circle is equal to 2 into A. Yes or not? Why? Because see, tooth thickness is equal to the tooth space. So if you same, so P is equal to 2 into T, and T is what? Tooth thickness, and here T instead of T it is given A. Clear? So PC, and this is equal to 12.566. So what is A value here then? A, it is your 6.28 mm. So this is your tooth thickness we have. Now we have to check the option. 6.28, 6.28, okay. So A and B value they are asking 6.28. So C and D option 6.2, A and B are wrong. So C and D are correct. 6.28, 6.28. C and D are correct. So we'll check C and D. How? If you find the value of B. B is what? This distance. B is not a tooth height. Tooth height is measured from tooth thickness to this one. This is below that pitch circle. Okay. So see this one. This is your B. This is your tooth, this is not a tooth thickness. B, it is your from measure from the pitch circle. This is your, so this is your addendum. So we have to measure the B, and B, it is your tooth. Let's measure from this circle. So from here to here, this is your B value. What is the B value then? So if you calculate the B value, apply the geometry rule. What is that? What is R here? What is R beta? From figure, what is R? R is equal to X plus Y, yes or not? Please see. X plus Y, or yes or not beta? X plus Y, yes or not? Please tell me. X plus Y or not? Yes, R is equal to X plus Y. So what is X value? R minus Y, correct. We will use, no problem. What is Y? So this triangle, what is Y beta? This is 90 degree. So what is Y? Y is equal to square root of R square. Y is equal to R square minus this A by 2. A by 2 whole square. Clear or not? This is A by 2, na? This is A by 2. A by 2. This one. Yes or not? A by 2. So if you put this value, what is R? R, it is your 64 whole square. A is what beta? 6.28 by 2 whole square. If we calculate, this is your 63.92 mm. This is Y. So if you have a Y value, you can easily find this X value. This 64, radius is what? 64 minus 63.92. What is the X value then? The X value, it is 0.08 mm. Yes or not? 0.08 mm. Once you have a X value, so what is B beta? Then what is B? B is equal to addendum plus X. Yes or not? Addendum plus X. What is addendum? Here addendum is equal to 1 module. And how much module it is given? 4 module. So addendum is 4 here. 1 module. Addendum is equal to 1 module. So here addendum is equal to 1 module, and module it is given 4. 4 plus X. How much it is? 4.08 mm. So this is B value. Clear now? This is B value, 4.08 mm. So please check this one, 4.08. Which is closest? C and D 6.28, 6.28. That is correct. Second option, category B, and B is 4.08. So 4.08, it is closest to 4.1. It is closest to 4.1. So option D is correct. Option D is correct. Okay. Option D is clear. This question is clear, beta. Please tell me, everyone. This question is clear. So these are the question related to the gear. This is clear, everyone. Please tell me. This is clear or not? This question is clear or not, beta? This question is clear or not? Simply geometry. Okay. This question is clear or not? Please tell me, everyone. This is clear or not, beta? Please tell me. Clear? If it is clear, then we go to the next problem. So that is the next problem. See this question related to the joints. What is that? A bolted joint is shown below. It is given a bolted joint. The maximum shear stresses in megapascal in the bolt A and B respectively. You have to find it. Okay. Maximum shear stress in the bolt A. This is the bolt A and a bolt. This is the bolt B. Maximum shear stress in the bolt A and B, you have to find it. Okay. Now here something is, we have to take this question intentionally. Why? Because there is something, another data it is given. See my dear, the dimension, the notation it is given, 3 hole 1 A B C of M10 cross 1.7 bolts. What is that? What is mean by M10 cross 1.7 bolt? So how to represent 3 hole, number of hole? If there is a 4, so you have to take 4 hole. M10 1.17 bolt. What is this one? Please, first we will think that. Now second one, load is apply on this one, and see, these are the symmetrical. These are the symmetry. Why? Because space, both this load, this one, all the space are same. 40 foot. This is 40 and this is 40. So this is at the center. This bolt, it is at center. Now that means how it is bolted. This is your base plate. Over the base plate, this is your bolt, like that. So it will try to twist the bolt. If you apply the load, it will try to twist the bolt. So due to twisting, there must be a shear stress. That means torsional shear stress will produce. That means it will be, because it is in plane. So in plane there is a twisting is there. That means this is your bolt, this is your plane, and this is your bolt. Now, and this is your plate. This is your base plate, and this is your bolt, and this is your plate which is showing here. Now if you apply the load, this plate is try to rotate. So due to rotation, this bolt is try to twist it. So during the twisting, the torsional shear stress will produce. So what is the torsional shear stress will produce? Now, so if we draw this one, try to solve this question, no problem. Okay. So this is your base. Okay, and this is your plate. Let's suppose this is your plate, no problem. And this is your plate. This is your plate, like, no problem. No problem at all. Okay, it is total. This is your plate, like. So this is your plate. Let's suppose this is your plate. Okay, this is your plate. Clear? Now you have to apply the load. So there is a bolt is there, 3 bolt. First one here. Second. Third. 3 bolt is there. Clear na? 3 volt is there. Now this bolt, so 3 bolt, and the distance it is given from here to here, distance it is given. All dimension are in mm. 40 it is given. 40 it is given. Again this is 20. Clear? Clear? Now we apply the load here. From here you have to apply the load. Let's suppose if force will applied. So on this one, this force is applied, and due to the eccentricity, this is eccentricity, and the distance it is given. From here, the distance it is given how much? From this one to this one, the force, application force. This distance it is given how much? This distance is 150 mm. From this CG of this bolt. Okay. Now, if this force is applied, this force first gives the two effect on this bolt. What is that? One is the direct load. Second one is due to the torsion. It produces a torsional effect. So, if we apply this force F, if apply this force F, all the bolt, the direct load it is there. On all the bolt, there is a direct load. So here, the direct load downward. Okay, delete this one, this color. Here the direct load on this bolt, direct load on this bolt, direct load on this bolt downward. Clear? And okay, and my dear, so this one is the primary shear load. Yeah, direct shear load. So primary shear. So this bolt is A. This is your A, B, C, and all A, B, C are equal primary shear load will act. So FP is equal to, FP is the primary shear load. Primary shear load. And what is the primary shear load? How many the number of bolt? N is equal to 3. So primary shear load is how much? If it is given, how much the force? 10 kilonewton is applied. So 10 kilonewton, that means 10 by power 10 to the power 3 Newton for 1 volt divided by 3. So how much it is? 3333.3 Newton. So this much load will applied on each bolt in downward direction. Okay. What is the cross section area of this bolt? Pi by 4 d square. Now what is the diameter? It is given or not? The diameter of the bolt it is given. Please see. Diameter of the bolt it is given or not? Please tell me. Diameter of the bolt it is given or not? Please tell me. Yes, it is given. See, 3 hole of M10, M20, M30, M6, that is your diameter. Along with the alphabetical corresponding the numerical value, that is your diameter. So M10 is the diameter of the bolt. So here 3 hole, 3 bolt of M10. So this 10 it is your diameter of the bolt. So mm, so pi by 4 into 10 to the power 2. This is how much? 78.54 mm square. This is your area. This is your cross section area. So what is the shear stress then? Primary shear stress. This load FP divided by this cross section area. Okay, see, this is your bolt, this is your bolt, and this is your cross section area. Yes or not? And this force is applied in this direction. FP. So this will apply the shear the load. This try to shear the bolt. How much it is? If you solve, this is your 42.44. 42.44 mega Pascal. This is your primary shear. Now, my dear, we have to find the secondary shear. How to find the secondary shear? How to find the secondary shear? Please tell me. How to find the secondary shear? Okay. How to find the secondary shear? If we apply this load downward, if you apply the load, this load downward, this bolt, okay, this is look like that. This bolt try to pull in this direction. One second. In this direction, and here there is no effect. Why? Because this is at the middle, and in this one it is in this direction. So this creates a secondary shear. What is that? This force into perpendicular distance. You have to find the secondary shear. Force into perpendicular distance eccentricity is equal to secondary shear of, let's suppose, A, bolt A, and both are the same, divided by the distance from this CG, 40, into this length, L1 square plus L2 square. This is the equation. हाँ, यस, कोई भी नहीं देख रहा, बाद में देखेगा बेटा, बाद में देखेंगे, बाद वाले के लिए कोई दिक्कत नहीं, नो प्रॉब्लम, नो प्रॉब्लम बेटा. So FE, no problem. If this eccentric load into eccentricity, secondary shear divided by 40, 40 is what? This bolt is your CG. This bolt is your CG. So from this CG, the distance is there. This distance is your L1. From this CG, this bolt distance is your L2. Clear? So if you put all, and L1 and L2 both are same, 40. So if you calculate this one, put all this value, so FSA is equal to 18.75 kilonewton. This is your secondary force, shear force on bolt A, and this secondary shear force is equal to that A1. That means what is the what is the secondary shear at bolt A is the same as B. Why? Because they both are the symmetrical about this B bolt. Clear? So this is also FSC. Clear? Now, so they are asking that what the question they asked, the question the maximum shear stress in the bolt A and B. So my dear, in the bolt B, the maximum shear stress is what? B. Maximum shear is only primary. Why? Because this is at CG. So for the primary, how much it is? 42.44. So bolt B, 42.44. See, 42.44. Option A and C may be correct. A 42. See, B on the B, bolt B, only the direct shear will act, and the direct shear is only the here the direct shear will act primary shear. So the primary shear on the bolt there is no any secondary shear. Why? Because the B it is at the CG. B it is at CG. So B at it is a CG, so there is only direct shear will act, and that direct shear value is 42.44. That means A and C options may be correct. Now we have to check bolt B. Why? Because on the bolt A. Why? Because bolt A there is a direct shear, also there is a secondary shear. So we have to calculate the resultant. Okay. So what is the resultant? That means, see my dear, that means this is your bolt. There is a F primary A bolt, this is your A bolt, and there is a F secondary, and F secondary you have just now. So there must be a resultant R. What is this resultant, beta? Square root of F primary square, F secondary square. What is F primary? F primary is what? If you put the kilonewton, so this is your 3.33 kilonewton, 3.33 kilonewton square. What is the secondary? What is the secondary? 18.75. 18.75 square. Clear? Now we have to put this value, calculate this one. This is your 19.04 kilonewton. So this much amount. Now, so what is the maximum? A and C. What is the maximum? Then this is force. So maximum, this force R divided by area. So what is this R divided by cross section area? This is your secondary. So what is R? 19.04. Cross section area is your pi by 4 d square 10 square. How much it is? 242.5 megapascal. This is your secondary, and it will act A and B both, A and C. This is your maximum. So 242.5, 242.5, 242.5, 242.5, 242.5, 242.5. That means option, which option is correct? 242.5, 242.5, 242.5. A, 242.5. Option A is correct. On the bolt A, 242.5, and on the bolt A, only primary, that means 42.5. So option A is correct. Okay. So this type of problem you must have to revise, so that, so again I give you again there is a one motivation, beta. See my dear, do not think over. आप बिल्कुल ज़्यादा मत सोचे, पहली बात तो ये है, बिल्कुल स्टिक रहे, जो रिवीजन आपका हो गया है वो हो गया है. ओके, ये सेशन ऐसा नहीं कि भाई ये सेशन से आपको ये लगे कि सर ये क्वेश्चन इस तरह का तो सॉल्व नहीं किया, आपको करना पड़ेगा, क्योंकि ये क्वेश्चन ही पूछते हैं गेट में. मैंने थर्मो का लिया, थर्मोडायनेमिक्स, fluid mechanics, machine design, all this type of questions you must, and also you have to go through, but you don't bother about it. Why? Because tomorrow you have exam for the mechanical student. So be calm and be cool. जो बीत गई सो बीत गई, तकदीर का सिकवा कौन करे, जब तीर कमान से निकल गई तो उसका पीछा कौन करे. टाइम खत्म. अब तो जो आपको है उसी को आप मनन कीजिए. न आज आपको ना पेन भी नहीं चलाना, बस मनन करना है, दिमाग में रिवाइज करना है. रिवीजन स्टार्ट, मतलब बैठ जाइए आप आराम से बढ़िया चेयर वेयर पे और उसको रिकॉल कीजिए. अगर आप चाहते हैं तो ये भी मत कीजिए, कल बढ़िया नींद लीजिए और सोने जाइए. दैट इज द गुड मेथड. आई एम टेलिंग यू, देयर इज अ वेरी बेस्ट मेथड फॉर दैट. ओके, सो बी केयरफुल एंड आई नो दैट योर प्रिपरेशन इज गुड. Your preparation is good, no problem. Just be focused on that exam. You have to part that exam into 3 part. First, you have to solve a very easy problem, then moderate, then tough. Don't stick with the toughest problem. Why? Because sir, I will revise more and more. Matlab, I have a command on this subject, and for this subject I am never leave the questions. Why? Because this is my favorite subject. Don't try to मतलब you have मतलब इस तरह के आप पॉइंट ऑफ व्यू लेके एग्जाम में मत बैठे. ओके, नॉट इगोस्टिक, सेल्फ इगो नहीं लेना. नहीं बन रहा, आगे बढ़ना है, क्योंकि आपके पास नंबर ऑफ क्वेश्चन ज्यादा है. ओके, 2-3 बार क्वेश्चन को आगे पीछे देख लीजिए पूरा. उसको क्वेश्चन बन रहा है नहीं बन रहा है, आगे बढ़ते जाइए. एक बार पहले फर्स्ट आवर में आप पूरा क्वेश्चन एक बार इधर से उधर, इधर घुसना उधर निकल जाना, इस तरह के सभी क्वेश्चन को देख लेना. उसमें से पहला 1 आवर आपका अच्छा ही रहेगा तो आपका रैंक बनेगा. पहला 1 आवर डिसाइड करेगा, लास्ट का 2 आवर नहीं. फर्स्ट 1 आवर इज डिसाइडेड फैक्टिंग. ओके, डिसाइडेड फैक्टिंग. ओके बेटा, थैंक यू, बाय बाय, गुड लक.